All right. Let's. This will be 2 lessons. It will not be a short lesson if it's 1 lesson. Yeah. I was gonna do 1 lesson, take like 5, and then the other lesson. Yeah. So, logarithms. We kind of talked about a logarithm. So I want to talk about logarithms in a little bit more detail. This is not going to be any logarithms that we covered last year in Algebra 2. Okay? So this is definitely new material for just about all of you. Cool? Yay. Okay. So we kind of already talked about log base 2 of 8 is equal to 3 is the exact same thing as saying 2 to the 3rd power equals 8. Those 2 things mean the same thing. They're just kind of written 2 different ways. So, in some respects, when I ask you what is a logarithm, well, the answer to the logarithm is an exponent. So, a logarithm is, in fact, an exponent of something. So, a lot of the rules of exponents also apply to logarithms. So, as we talk about these different rules with logs today, our goal in doing so is to rewrite things in equivalent forms to make things a little bit easier to manage depending on what we need to do. And the thing is, sometimes it's going to make sense to do one skill and sometimes it's going to make sense to do the other. Okay? Now, guys, if I asked you what is log base 5 of 382, what would you do? Yeah?
I'd rewrite it.
As?
5 to the x power equals 380.
Okay, so we want to find the value of log base 5 of 382, right? We don't know what the value is, so we could rewrite that in exponential form, get 5 to the x equals 382. Cool. Then what? Can't take the square root, because the square root of 5 to the x is the square root of 5 to x. We're going to log both sides. Or use guess and check, but I wouldn't. Do you want to guess and check when it's going to be a decimal?
No.
Okay. So we're going to get x times the log of 5 equals the log of 382. Yeah.
Divide both sides by log 5.
We'll divide by log 5. I don't know what the answer is because I just made it up. I can guess though. I would bet 5.61. Okay, so just so you guys know, I got the hard part of guessing right and the easy part wrong, but that's a whole other conversation. Okay, so how do we find logs when it's not that, because you guys don't have like log base 5 in your calculator, right? You have log, which is log base 10, and you have natural log, but you don't have a log with a different base. So the first formula, property of logarithms we're going to do is something called the change of base formula. And it's if I have a base that I don't know how to work with, like one of the ones that's not in my calculator, what I can do, well, like notice that what did we really end up doing here? We did log 382 over log 5. So what in doing that, we shifted from log base 5 to log base 10. Because there's like invisible 10s here. Okay? So if I have log base anything, I can rewrite that. All right, so how can I rewrite log base 5 of 6?
Log 6 over log 5.
Log 6 over log 5. What ends up happening, you guys, is the base goes on the bottom. Is that kind of easy to remember? The base goes on the bottom? And I have no idea what that is. I'm assuming it's like 1.1 or 1.2. What about log base 8 of 64? How could we rewrite it? Now, log 64 over log 8. Yeah. Now, did we need a calculator for this one, you guys? 8 to what power gives me 64? 2. You didn't need a calculator for it. But if you use, this does work to get around that calculator, yeah? If you don't recognize that 8 squared is what gives you 64, it's fine. You just, if you don't recognize it, what you have to do is, you know, all the work, yeah.
Are you going to show us how to change the base in the calculator? Because I know you can do it, and I know how, but I don't know if we're allowed to do that.
Not right now,
Okay.
because I'm focusing on what the log properties are right now. We ready? All right, now, guys, if I have x to the 9th times x to the 4th, what do we do with those exponents?
Add them.
Add them. Okay, so the product property is going to deal with multiplying and then what we do with exponents. So if I have log base a of b times c, what I would normally do is add my exponents here, yeah? Because I'm multiplying that b and the c, so I would add the exponents. So what we do is we just split this up into, you're allowed to split this up into an addition problem. The base would stay the same, just like this base stayed the same, when we split that product up into an addition problem. That's my first property. All right, what if I gave you x to the 9th divided by x to the 4th?
You subtract the
We would subtract the exponents, yeah? So if I gave you log base a of b divided by c, we could write that as log base a of b minus log base a of c. This is just different ways we're allowed to rewrite things. And then the last one, x to the 9th squared, if I'm raising an exponent to an exponent's power, I multiply, yeah? Likewise, if I have log base a of b to the c powered, I can write that as c times log base a of b. Now, the reason we do this is sometimes it's easier to see things in a different form, okay? Not any different, guys. If I ask you to do 1/3 plus 5/6, how would you do 1/3 plus 5/6? Yeah, so even though 1/3 seems simpler than 2/6, if what I need to do is add the fractions together, it makes sense to go ahead and write it as the less simple form, right? So rewriting things in different forms can make life easier depending on what we are trying to do. So that's our whole goal here. So I would like us to rewrite this in a different form. If I say condense as my directions, what I mean if I say condense is to write it so there's only one logarithm, a log of a more complex expression. All right, so the first thing we're going to do is take this 5 out in front of the logarithm and undo that power property. So if I do that, I now have log base 3 of 2 plus log base 3 of x to the 5th. Now, what did plus imply? That means we're adding exponents, which means we have a product. So if I take this one a step further, I could call this log base 3 of 2x to the 5th. So, depending on what we want to do, sometimes it might be easier to have that kind of expression. Sometimes it's easier to have that kind of expression. Both of them are valid. Like one's not better or more simpler than the other, just different ways of writing it. Okay? So, as I look at, say, this one, I might put the 2 here and the 3 here and get rid of them. Now, there is a typo, guys. These are both supposed to be x to the 4th, because if they're not the same base, there's not much more we can do. They're both supposed to be x to the log base 4, not log base 3 and then log base 4. Okay. So, my answer, if I'm subtracting, what does that say? Subtraction goes with quotients, division. So we're going to do log base 4 of x squared over y to the 3rd. I'll let you guys look at that for a second. This is fairly intense. How we feeling so far? Okay. And you had, I think, enough room to work it on the bottom of the other page. So log base 5 of x plus 6 log base 5 of 2 minus. Sorry about that. All right. First thing we're going to do, move those exponents up. All right. So basically, anything that's got a positive in front, positive exponent is on the top. Anything with a minus sign in front, negative exponent is on the bottom. Does that kind of make sense? Okay, so on the top of my fraction, I'm going to have x and then x minus 2 to the 6th. On the bottom, I'm going to have x plus 3 to the 6th.
that X come that's on the top?
The first one,
Yeah.
that's where it came from. So like, this is this X. This is this one. Cool? Yeah.
But why would it go up there during the property?
Say that again?
But why would it go up there?
As opposed to where do you think it should go?
I'm not too sure where I would think it would go, but I was just confused why would it go up there.
So, in some respects, because there's a 1 here, right? The exponent on that X is a 1. And if I really, really wanted to, I could almost think of this as a -6 because of that minus sign. And what do we know about exponents? Something to a positive power is being multiplied that many times. Something to a negative power is being divided. The way that kind of shows up in our fraction, positive exponents go on top, negative exponents go on the bottom. So when I see that this is a positive log, positive 1, this is an x to the positive 1 then. Positive exponents go on the top, negative exponents go on the bottom. We good? Okay. Oh, I got one more for us to do that's on the wrong page. Cool beans. Guys, I'm sorry about this. I'll put it, because it's on the wrong side for you guys too, right? Do you want me to just copy this on that previous page for you guys? I had one more example that kind of, my formatting got messed up. This is supposed to be at the, this is supposed to be at the bottom of the previous page, because you don't have enough room to work it here. Does that, you guys see what I'm saying now? So, x minus 6 log base 5. All right, so just like sometimes what we're going to do is condense and put them all together, sometimes it'll make more sense for us to expand them out and write them in several pieces. And it really depends on what we are doing as to when you want to do this versus something else. Okay, knowing that, the first thing I would do when I look at this one is I would say, hey, I want to get rid of that dividing sign. If I want to break it up into pieces, let's get rid of that divide. So I could rewrite this as log base 8 of x squared minus log base 8 of y to the third. Now, I might take that a step further and bring those exponents down front. So that would become 2 log base 8 of x minus 3 log base 8 of y. Just bringing those exponents down in front. Okay. What about this one? What do you guys think? Go ahead.
Log 7 of A5 minus log 7 of B9 multiplied by C2.
So, okay, sure. It might look like that then. So instead, is I might just think of this as minus log base 7 of c squared as well. Think of it that way. All right. Now, the only other thing, get rid of those exponents out front. Or bring those exponents down front, I should say. How are we feeling? All right, so next, I have 3 examples for you to do. You have 10 minutes to do them. You may take a break as soon as you have them correct by showing them to me. Do you guys see what I'm saying there? Back. All right, I forgot to record that first part, but that's okay. All right, help me out. We're practically pros at this now, right?
Yeah.
Everybody but Theo, and maybe Chai, you probably need a quick reminder of this, are pros at this. I'm going to write this as log base 3 of something, yeah? What do I have on the top?
X minus 1, x to the 5th power.
X minus 1, and then x to the 5th. And then on the bottom?
X plus 5 to the 2nd power.
X plus 5, the quantity squared. Told you. Pros. And that was the one you guys said you didn't know how to do. That was the one that all of you asked me for help with. What about this one?
You understand the answer?
Sure.
5 log,
Log base 5.
log base 5 x minus 6 log 5.
That 6 is on top, so positive exponent will be plus 6 log base 5 of y.
Oh yeah, plus 6 log 5 base y, and then minus log 5 base c squared.
Except for I'm going to bring that exponent of 2 down in front.
Oh yeah.
Good?
Fantastic.
If we can do this next part is not going to be so bad. Now, you guys, I want to talk about this log base 6 of 0 for a second. If this had been log base 10, would it still be no solution?
I'm going to say no.
Yes.
Can I say 10 to what power equals 0? Is that still going to be... Will 10 to a power ever equal 0?
No.
No. So, like, this was no solution. And the deal is, you can, when we say log base anything of 0 is undefined. Because it doesn't matter. Something to a power cannot equal 0. It's impossible. All right, so what we're going to start doing is solving equations that have logs inside the equation, okay? And it's going to depend on the situation what we can do here. Does that make sense? So sometimes we're going to use all these different properties to make it easier to solve the equation. So if I gave you log base x of 3 equals log base x of 125 equals 3, the first thing we might do, the first strategy I have is saying, hey, can we rewrite this in exponential form? If I asked you to rewrite this the other way around, how would it look? Yeah.
X to the 3rd equals 125.
X to the 3rd equals 125. Because exponentials and logs just kind of switch places, yeah? That's the whole point of the log. Now if I gave you the equation x to the third equals 125, how do I solve that?
Cube root it.
And so when my variable is the base, I can just take the root of both sides. When my variable is the exponent, that's when I have to take the log. But when it's the base of that expression, I can just take the third root of both sides. Do you guys remember where to find that third root in your calculator?
Math, and then you go down a bit.
Math, and then within there, I think it's math 4 is the cube root. And then if it were a different power, so you need to take the fourth root or the fifth root, I think it's option number 5 in the math menu, I think.
Yeah.
Guys, what's the fifth root of 120, or third root of 125? That's one of those times where my brain was moving, my mouth was moving faster than my hand was moving faster than my, you guys know what I'm saying. When you know the answer to something, you ask the wrong question sometimes. You know what I'm saying? Easy peasy, right? Okay.
This question.
Yes.
Could you go a little bit up? I did not. Thank you. Sorry. I appreciate it.
Anything for you, bud. Hey, what should we do here?
Could we just divide out log 3?
We don't even divide it out. I don't like the phrase divide it out because can I take a sidebar? You guys don't mind if I take a sidebar, do you? If we had like 2 to the 3x plus 7 equals 2 to the 5th, we're not, when we say 3x plus 7 equals 5, we're not dividing that 2 away. We're just kind of recognizing that these two sides will be equal when the exponents are equal to each other. Because this isn't saying 2 times 3x to the 5th. Times 3x plus 7 is saying 2 to that power. In the same way, this is not saying log base 3 times 2x minus 5. And so I don't want to think about it as dividing. Okay? However, I am very comfortable saying, hey, these two sides will only be equal when 2x minus 5 equals 5x plus 10. So we're not dividing them away, but they do kind of like counteract each other. All right. Now, what should we do next?
I added 5 and then divided by the 5x.
I'm fine with adding the 5.
Subtract
Yeah.
If I added that 5 first, then I would subtract the 5x and get negative 3x equals 15.
Negative 5 equals that.
X equals negative 5. Now, you could also, at the beginning, if you looked at this and said, oh, I'm going to subtract 2x first, that's fine. If I do that, then I get negative 5 equals 3x plus 10, and subtract the 10, and now we've got negative 15 equals 3x. So both of them are going to end up with x equals negative 5, yeah? All right. Guess what the answer is?
Negative 5?
positive.
Nothing. No solution. So I want to make sure turn your page real quick. So this is, can we talk about why this is no solution real quick?
Yes, I'm pretty confused.
All right. Guys, can we plug that -5 back in? We got log base 3 of 2 times -5 minus 5, yeah? That's what that left-hand side works out to be. Let's see, and that would be log base 3 of -15. Guys, can we do log base 3 of -15?
No.
And in fact, that would be 3 to what power gives me -15? That's why it's no solution. So what does this tell us? Well, when we go through and do these, we can't end up taking the log of a number that's less than or equal to 0. Okay? And if you go... Your guys' next page, is it? That makes so much sense. No, it makes sense of something that happened a long time ago.
Yeah, but I don't think we have that.
You don't.
No.
Okay. You're going to put this side in for y1. So you hit y equals. Walter, I'm not helping you on your calculator ever again, so... Yeah.
I forgot about that. What wasn't it like
Walter, I got this ad. I debated doing this for you. I got this ad that it was like if you take a picture, that you can take a picture and send it in and they'll make an ornament of it. And I was like, that picture of Walter falling into the sink that is on my phone. I was like, that would be such a hilarious Christmas ornament for him.
pay you for that?
I don't know how much it costs, but I have the, like, maybe what I'll do is I'll send you the photo. I'll airdrop the photo or something to you. So you can do it.
Yeah,
No, that's just between me and him. If I had, God, it was funny. God, that was a funny. So, Jillian, we were all lined up in the back, and Walter went to sit on the counter, and he fell into the sink, and it was a pretty hilarious. And then he got into one of his, like, Walter gets into this, like, laughing fit where he can't stop laughing, and it's pretty hilarious when that happens.
Who's gonna watch this recording?
Everybody who's not here right now.
I think I'm
I would say just.
Lily, Kaylee, Dylan.
Oh, Dylan's gonna have fun.
Eh,
This hand is
I
broken.
can't get to the always phone.
Okay, apps. Was it?
No, I'm there, just now.
It won't let me go down.
You hit it.
You hit graph.
You did.
$50 worth of
Yeah,
You hit.
because he spoke.
the graph button.
Oh, I forgot about that one.
Like the little.
Fire That'd be funny if they did not. But they did.
Those are just the coefficients, Mia. So that'll be the
Oh, so it'll just.
1, 1, and -6. Huh?
I used to love it, actually.
Okay, you guys, we're not done with this question.
Oh no.
Is x allowed to equal these things?
No. X can't equal two different. X cannot equal negative.
X can equal two different things. You can have more than one value that makes an equation true. However, if I take this -3, this becomes log base 11 of -3. Can we do log base 11 of -3?
No.
All right, when I plug the 2 in, does that one work?
Yes.
Does this one work? Yes. So my only solution to this is x equals 2. Let's do the next one. I'll give you some time to write it down though.
Oh no.
So you have to have this equal to 0, so this has got to go.
I'd like to commemorate it.
So you would have subtracted 6 from both sides, and then and so that A 0 is going to come up with 6. And then press graph to get there.
Ms.
Mhm.
Meister, what are we doing the day,
Yeah, we got the
like the Tuesday
Click there.
of winter break?
That's just not an issue. No.
Like next Tuesday, thank you.
You mean Thanksgiving break?
Yeah, that's what I'm
Project,
Oh, and when is that due?
Meister,
when we get back from Thanksgiving break.
so is all you need just the x equals -3 and x equals 3?
But x doesn't equal -3, because when we plug that in,
Alright.
okay.
Wait,
Alright,
You're introducing the project, or are we just doing the project?
I'm introducing it on Monday, you're doing the project.
Okay, 'cause I won't be there.
Okay, you guys ready for this next one?
No, probably not. It's unlikely.
Alright, I'm gonna leave the left-hand side as log base 12 of x. Are you guys okay if I put that 1/2 on the 9 and that 1/3 on the 27? And just move them up as exponents. So this becomes log base 12 of 9 to the 1/2 power plus log base 12 of 27 to the 1/3 power. Are we comfortable so far?
No. I just feel weird as exponents.
Okay, we learned these last year. You guys. 27 to the 1/3 power is equivalent to the third root of 27. I think that bottom number is just your root. And likewise, 9 to the 1/2 is the square root of 9. Okay? Guys, I don't know the square root of 9 or the cube root of 27. What's the square root of 9? What's the cube root of 27?
30.
Wait a second, this looks somewhere. Log of 12 of 3's
Probably
wait a second. My mind feels like turning.
So what's x?
What?
Log root, or log 12, 30 times 2.
Oh wait, can we condense that?
I would.
Can we condense that to log 12x equals log 12 parentheses 3 times 3?
So what's x? What do we think? Easy?
Definitely not easy,
Definitely not easy.
but like achievable.
Oh, that's exactly what I would want for you guys. Not easy, but achievable. Because you guys don't want to do things that are easy.
Well, I do, but you know.
Easy is boring.
Depends on what it is. You're not saying anything, so.
Thoughts on this last one?
This class has gone by very fast.
How do I do this? Yeah.
Condense.
You guys cool if I call this log base 4 of x minus 3 times x plus 3 equals 2? Good so far? Now what? And there are two possible next steps. Both of them would be completely reasonable. Can we cancel out the log?
No.
That's a problem. How do we get rid of it then?
I feel like since it's x minus 3 and x plus 3, we can do something there.
Okay, so we'll do that as our first step. So we're going to do x times x. We can do that distributive property that you guys have been doing for a long time. If I do that, you guys, I end up with x squared minus 9, because you're going to end up with plus 3x minus 3x. So we now have log base 4 of x squared minus 9 equals 2. But like at least for the previous ones on this page, we've always had two logs that we could just kind of like take away from each other. But we don't have logs on both sides here. So what do we do?
Oh, do we do the thing where we switch it around?
Yeah. Can I rewrite this as 4 to the second power equals x squared minus 9? And if that's the case,
Can we take the square root?
before we do that, we're going to get 16 equals x squared minus 9. And then from here, I don't care how you solve it. I think adding 9 and then taking the square root is probably the easiest way to get there. Are we comfortable with that idea? The base to the power, like I'm rewriting it in exponential form. So when I have a log on both sides, I can just cancel those logs out. If I don't have that log on both sides, I'm going to have to rewrite it in a different form. So I get x squared equals 25, yeah? So x equals 5 and negative 5.
But you can't do both.
But x isn't allowed to equal a negative 5 because if I plug negative 5 in, I'm taking the log of a negative number. Yeah?
I missed what you did from the 16 equals x squared minus 9.
It's all good. You guys have a lot that you're trying to focus through right now. Yeah. How are we feeling, okay? Right on.